So we are good to go. Good afternoon once again, and welcome to lecture 3. And in this lecture, we are going to, of course, before now, we have discussed sampling and data collection. In the last class, we focused on different sampling techniques. And if you have gone through the meeting, the note generated by Gemini, you will see the summary of our discussion, the introduction to sampling in linguistic research, the types of sampling bias, the probability versus non-probability sampling, the simple random sampling, the stratified. Those are probability sampling techniques. The non-probability is convenience sampling. And we also I don't know what's... So something went wrong. Gemini could not take notes. Let me see what went wrong. It's good to take notes. If it's not taking note, I may need to refresh. We need the note for our record. So let me refresh.
Sir,
We
you are
can't hear you,
muted,
sir.
We can't hear you, sir.
Oh, sorry. Can you hear me now?
Yes, sir.
Sorry for that. I still don't know why. Okay. I hope the lecture is being transcribed. So we discuss ethical issues, and then attended to some questions and comments, and then we ended the class. All these are useful references for you, to help you navigate through the course successfully. For today, our focus will be okay. If you are removed, make sure you join back again. Yeah. So let me share my. Are you able to see my screen?
No, sir.
Okay, I'm sharing my screen now. So this is the lecture note for lecture 3, and in this lecture, our focus will be on the fundamentals of hypothesis testing. As much as possible, I've been very careful to only focus on what you need as a linguistic researcher. For your computational linguistic data. But we can't eliminate symbols. We can't eliminate, underlying principles completely, because that again will not help you. So you need to have some basic knowledge about the technique, and also connect them to linguistic data set for your research. So for today's class, focus will be on hypothesis testing. So we are going to understand what hypothesis testing means, and we are going to look at the two types of hypotheses that are used for arriving at a decision. And then decisions can arise and yet may not be the correct decision. So a decision can be right or can be wrong. We will now see two types of errors that can be committed. Sometimes our decision to reject may end up rejecting a correct hypothesis. That will be an error, because our interest is to accept a correct hypothesis. Sometimes also we may end up accepting a wrong hypothesis. That's another error. So those are two types of errors that can be committed. But we will give them, we'll talk more about that in this lecture. And how do we arrive at decision? So to arrive at decisions, we need to use statistical tools. and among them are p-values and significance levels. What do they mean? That you will also understand what they mean and how they are used in hypothesis testing or in decision making, so to say. And before we close the lecture, we will discuss two major no, we will discuss the tool, one tool that is used actually, which is the t-test. But this t-test can be used for one sample and also for two samples. And we are going to demonstrate with example. So, but before we even look at that, let's look at this data, which is a typical data in linguistic. One common thing that I think you do in linguistic is to look at speech rate. Speech rate, I don't know the definition you give to it, but it differs, but it could be measured as the number of words spoken by an individual per minute. And it varies. So the number of words that I speak per minute will likely be different from your own, and your own will be different from others too. So we might be interested in measuring that. So in this data, for instance, we are looking at data that contain speech rate of 10 speakers. Speaker 1, speaker 2, speaker 3. So we have 10 of them and their gender. The first speaker is a male. The second is a male. They don't have to follow like this. Hello, at what point did we miss did, did I get you did I disconnect? Hello?
Yes, sir. You were explaining a particular linguistic data, which is speech rate, and you're defining the concept of speech rate that it has to do with the measure of individual speech and number of words per minute. That's what I got before you.
Excellent. It appears you are the only one in the class. So I was trying to give a background to the kind of thing we want to do. We have 10 speakers, we have the agendas, and we have their speech rate. And I said, one, we could test hypotheses regarding the average speech rate for male. We could also test hypotheses regarding the average speech rate for female. So we can test the male. If we do that, then we will be talking about a single test. If we now test whether male average speed rate is the same thing as female average speech rate, then we are going to be talking about two independent samples. So those are things we want to talk about in this session. So that takes us back to our lecture note. Except you have questions. If you have questions, you are free to stop me, unmute yourself, ask your question. Is anybody admitting new people to the class? I can see some people trying to join. Is anybody admitting?
No, sir. I'm not admitting, sir.
Huh?
Not from my hand, sir.
Nobody. I saw someone wants to join. Let me see. Maybe I will make one of you to become. Who is the class president?
Habib, sir.
I am first, so let me.
No, it's Habib. Sorry, it's Habib.
Habib.
Yes, sir.
Okay, Habib. So that's Cassava. Yeah. So I make you a co-host. That will. You are now a co-host, and you can admit anybody that is joining.
I'm sorry, sir. I'm having network issues, sir. I'm sorry.
Okay. Then who else is willing? Who else is available and willing? Eddie Young, are you? Deborah?
I can volunteer, sir. I can volunteer, sir.
Okay, Deborah is a good volunteer. Thank you. So let's move on. So now, what is hypothesis testing? So it's a statistical method and is used primarily to test a claim or to support a claim or to reject a claim. So I can claim that the average speech rate of the student in this class, for instance, is 150. That's a claim. And I need this statistical method to be able to, say whether that claim is supported by the data that I have or not. So I will need to make, use the data as evidence, and then establish whether that data support the claim that I made regarding the speech rate of the class. So it's a statistical method and is used to establish if we have enough evidence to support a claim, about the population based on the sample data. And I've said earlier that we can have our population, we have population, and if the population is too large, we can use a sample. So when we collect sample, we can make a claim about the population and say the population of students in the linguistic department, that the average speech rate of students or lecturers, we have to define our population, but let's say we are focusing on students. So we say that population of students is the square bracket that you see there. So that is the population of students. So this represents the population. So we can make a claim about this population and say the average speech rate of students in linguistic class is so, maybe 150. Whereas we may not be able to cover the entire population for whatever reason. So we take sample. So the one we take is this. This is our sample. And then based on the information that we get from this sample, which is now our evidence, we can now use hypothesis testing to determine if the data in the sample, if the information is in the sample, if the evidence in the sample is enough to support the claim about the population, no, or not. So that is the essence of hypothesis testing that we are discussing with respect to linguistic data. So in the linguistic environment or field, we can use hypothesis testing to establish pattern that we observed, whether in experimental data or observational or survey data. Example of situations that we can consider here is, for instance, if one is interested in the question, answering the question, do bilingual speakers switch languages more frequently in informal settings than in formal settings? Who can explain what that question is actually aiming at? Who can explain what that question is aiming at? Do bilingual speakers switch languages more frequently in informal settings than in formal settings? Deborah, let me start with you. How many languages do you speak? Deborah, has she left the call? Cassava, how about you? Again, Cassava left. Eniola,
Yes, sir.
how many languages do you speak?
2.
2. What are they?
Yes. English and Yoruba.
English and Yoruba.
Yes, sir.
When you are speaking English, do you switch to Yoruba occasionally?
Yes, sir.
So you cannot, like, how many words will you likely speak before you interject it with another language? Maybe if you are speaking Yoruba, you suddenly switch to English. Do you have idea, or is so frequent?
It's not so frequent, sir. Like, for example, I can relate this to a formal setting, so I can speak English without code switching. But when I'm with my friends and I speaking in English, I
Yeah.
tend to be more comfortable, so I
Okay.
just switch
So
frequently. Yeah.
this. Okay, let me hear from. Is anybody also contributing to this discussion before I move on? Yes, Robert.
Yes, sir. Yeah. I think that hypothesis is right. If I'm with my friends, I'm in an informal setting, I switch more as a bilingual. I speak English and Yoruba, so I switch more than if I'm in a formal setting. The consciousness is there that when I'm in a formal setting, I tend to adhere to the language I'm speaking.
Now, Robert, before you leave, what gives you impression that that question is right?
Yes, sir. Please come again, sir.
What gives you the impression that that question is right? You started by saying, yes, that question is right.
My own personal observation. Personal observation.
But the question is about bilingual speakers, not about Robert.
Okay,
Right?
sir. Okay, sir.
So what that means is that you need to collect data. Yes, cassava.
Sir, I believe bilingual speakers switch languages more frequently in informal setting because
Yeah,
in most cases there will be some interjection, there's some words of other languages that just put in just
yeah,
for just even unconsciously in most cases.
good. The issue is this. your belief is not acceptable in scientific inquiry. You can start your you can build your premises on your belief, fine, but you need evidence that will make it generalizable. Yes, Edidion.
Yes, sir. I want to contribute to that example.
Yes.
From my own end, I don't really believe that bilingual speakers switch languages more frequently in informal setting. I believe it depends on to whom one is communicating. Like here that we are in school, I have friends like Kola, I have Abib, and other friends that do not speak my language, my L1. So if I'm speaking with them as friends in an informal setting, I will not expect myself to be code switching. But if I'm speaking with a Didion here, without any scientific approach, there's every tendency that I will code switch.
So,
if we are saying that bilingual speakers switch languages more frequently, I believe that there are a whole lot of factors that should be considered to whom the communication is being carried out with should be considered. Because if I'm speaking with Kola, that is my friend from Yoruba, I cannot switch it to my language. I've not seen that happen before.
Okay, for the last time, cassava, because of other things we want to cover.
Okay, so I believe what Udo said is right, and in addition, sir, it depends on the fluency. If someone has the same level of fluency in both language, automatically it doesn't matter who the person is speaking to. There are sometimes when you are speaking in Yoruba, then it doesn't matter who the person you are speaking to, or you are speaking in English, just add some words. So it doesn't matter who you are speaking to. It matters the fluency, how fluent you are in both languages.
Excellent. So this is why we are studying hypothesis testing, because now we have a claim that we all have different opinion about, and beyond that, we can now statistically, given a specific environment or given a specific group of speakers, we can now study their language switching frequency and see whether when they are in informal settings, they switch language so frequently or not. So how do we now come to a conclusion that is scientific, systematic? So this is what hypothesis testing helps us to achieve. So you can raise any scientific question of this type, and then you will now need to test that kind of claim. So I can focus on these students in this class. I can focus on a particular group, a particular environment, a particular informal setting, and so on like that. We will now define that place, and then we collect the data, and we say, okay, when bilingual speakers are in this particular environment, or they are made up of this particular group, they tend to switch frequently. So this is a typical example of the application of hypothesis testing in linguistics. So the idea is we are building the foundation for this discussion. And that leads to two types of hypotheses that can be tested. The first one is called the null hypothesis, and is usually denoted by this symbol, H, subscript 0. So sometimes we write it as H, like this. So when we write this, it is called the null hypothesis. The alternative hypothesis, which is this, is also written either as H subscript 1 or H subscript A. So for alternative, we can have 0. For null, we can have 0. But for alternative, we could have H1 or we have HA. You can be consistent with your preference. Doesn't matter. But what is null hypothesis? Is usually the hypothesis that is saying there is no effect or there is no difference. So it is the hypothesis that we consider to be true until we are able to prove otherwise. So it's usually what we know about that thing, or what is already what has been settled in the literature. What does the literature say about this subject of speech rate between male and female? What does this literature say about the subject of the frequency of language switching among bilinguals? So these are the null hypothesis is hypothesis that is telling us about what we already know until we are able to prove it. So, for instance, the null hypothesis will say there is no difference in speech rate between male and female. So, the null is here saying no difference, that the male and female are speaking, the speech rate, they speak the same number of words per minute. So that's the status quo. But the alternative is the one that counters it, is the one that opposes the null. So when the null is saying there is no, the alternative will say there is. So if it says there is no difference, the alternative will say there is a difference, or a difference exists. When the alternative is saying there is no effect, when the null is saying there is no effect, the alternative will say there is an effect, significant effect. So in this case, where we say there is no difference in speech rate between male and female speakers, then alternative we say there is a difference. In fact, alternative can even say male speakers have a faster speech rate than female. So a particular direction can be given. So two things can happen. So male, if the null is saying no difference. If the null is saying no difference, then the alternative will say difference. And it could also go further to, of course, another hypothesis alternative could say male is greater than female. This one, we can also say male is equals to female. No difference means both are the same. Alternative, this is one alternative, this is another alternative, this is one alternative. Of course, there could even be another one, another alternative, which we say male is less than female. So this is another alternative. But this alternative sorry, this one actually is not no difference. Difference means male is different from female, but no difference means male is the same as female. So this is no difference, male is the same as female. The alternative could be either of these three. But the point we want to make here is that in these two, we can see direction. Male is less than female. In the second one, male is greater than female. So we have directions. But in this third one, it's only saying there is a difference. This one is saying there is a difference, but it doesn't show the direction, whether male is greater or less. Do you understand this particular slide? Is there any question, anything for me to clarify on this slide? So in this slide, the interest is to distinguish between the null hypothesis and the alternative hypothesis. And the alternative hypothesis, yes. Who raised hand? Your network is not good. Let me see if I can see the Ganiyat. I raised my hand to point out them. Okay.
Yes, I wanted to point it out that M equals female is it should be null hypothesis since there's no difference.
Yes. Thank you very much. Are you okay now?
Yes, sir.
Great. So the null hypothesis is the one that is saying no difference. The alternative is the one that is saying there is a difference. But the alternative can also go further to show the direction and say male is less than female or male is greater than female. So that takes us to the steps that we need to follow whenever we are testing hypotheses. What is the first step? What is the second step? What is the third step? So the starting point is the formulation of the hypothesis. The formulation of the hypothesis. So when you are formulating statistical hypothesis, you need to state what the null is. And you also need to state what the alternative is. So we usually say the null versus the alternative. The null versus the alternative. So there will always be only two hypotheses. The null first, the alternative follows. The null saying no effect or no difference, the alternative saying there is a difference, or one is greater than the other, or one is less than the other. So you could have a direction, you could also have a directionless alternative hypothesis. So formulating the hypothesis is the first step. The second step is to choose what we call significance level. Significance level. Significance level, we always write it as alpha. Generally, it could be 0.01, could be 0.05, it could be 0.10. What does that mean? The significance level that you choose represent the probability of doubt that you are willing to entertain regarding the decision you take on the null hypothesis. You don't want to reject the null hypothesis when it is true. You don't want to do that. So you want that probability that you will reject the null hypothesis when it is true to be very, very, very small. So that's why I say is the level of doubt that you are willing to accept, to tolerate, as far as your decision on the null hypothesis is concerned. So it's usually a very small value, but in social sciences, in art like your own, you can always stick to 0.05 as your significance level. So, but you need to choose that level before you even collect your data, before you even gather your data, or before you analyze your data. You need to choose that level. And that's very, very important. Otherwise, you might be tempted, to choose to shift the goalposts, when you are about to, a score, or the kick is coming. So you don't wait until you see the result before you choose your level of significance. It has to be, you have to choose it before you even collect your data. So that's the second step, selecting a significance level. So I've advised that for now, stick to a significance level of 0.05. The third step is to choose an appropriate statistical test. And these are some of the tests that we use in statistics: t-test, chi-square test, ANOVA. There are other types of tests, several types of tests. But time will not permit us. We will only focus on the t-test in our example. Then the question is, when do you use the t-test? So you use the t-test when you remember, was it the lecture we had the other time on machine learning? We were talking about regression, and I told you of dependent variable and independent variable. Independent variable. The dependent variable is the variable that you are explaining, whose value will change based on the values of the independent variable. So the independent variable is the one that is explaining the dependent variable. So if we go back to our data, the data that I showed you regarding the speech rate, here in this case, the variable that we are trying to explain is the speech rate. And we are saying this speech rate might differ or depends on gender. It is not gender that we are explaining, but it is the speech rate that we are trying to explain. So in this case, speech rate will be our dependent variable, and gender will be our independent variable. And so, yes, okay, I didn't left. So it's always very, very important that when you are using the t-test, you know which variable is your dependent and which variable is your independent. The other thing is that your dependent variable must be a variable that is quantitative, like the speech rate. And your independent variable will have to be a variable that is qualitative, which means it's in categories. So it's a categorical variable. So let's go back to the slide. So we can. So we in the third step, we have to choose the appropriate statistical test. And for our data now, I've shown you why t-test is chosen because one, our dependent variable is the speech rate. Our independent variable is gender and is categorical. It has two categories. If you have more than two categories, let's say we are looking at speech rate and maybe for the student, we are looking at maybe class of degree. No, and we will have those in the first class, those in the second class category, and maybe those in the third class category. Then we will have 3 levels here. In that case, we won't be able to use t-test. That's when we will use the analysis of variance test. So we will still discuss some of this in subsequent lectures. Now, what's the third step? After we have chosen the t-test, then the third step is to compute the t-value. If we have chosen the t-test, then we will need to compute the t-value. If we have chosen the chi-square test, then we will need to compute the chi-square value. If we have chosen ANOVA, what we will compute is the F statistics, which is not stated here. So whatever test you choose here is going to determine what the test statistic that you will compute in the fourth step. Having done that, now that we have computed the t-value, we are now at the point of comparing the critical value or the p-value to be able to take a decision regarding the null hypothesis. Whatever decision we take about the null hypothesis will also have implication on the alternative. For instance, if I reject the null hypothesis, what that means that I will say we don't have the evidence that we have is not strong enough to accept the null hypothesis. So, which means the evidence is not strong enough for us to accept the null hypothesis. So which means the test is not significant. But if we have overwhelming evidence against the null hypothesis, that's what the critical value and the p-value will help us to determine. What is the volume or the nature of evidence that we have? So is our evidence supporting the null hypothesis, or our evidence, against the null hypothesis? So we will compare critical value with the test statistics, or we compare the p-value with the level of significance. So this is what is done here, comparing p-value with the level of significance, alpha. So if the p-value, of course, when you use computer or any computational software, you will be able to get the p-value, and then you'll be able to compare with your selected level of significance. So you are to reject H naught if the p-value you have chosen, you have computed, is smaller than the alpha value that you have chosen. So what that means is that you are rejecting H naught, and the implication is that the claim, the test is significant, that what is in H1, your claim, which is in the alternative, is true as far as the evidence or the data is concerned. Now, if the reverse is the case and the p-value is bigger than the alpha value, then you fail to reject the null hypothesis, which means the evidence you have is not strong enough to reject what we already know about that phenomenon, or what the null hypothesis, whatever is stated in the null hypothesis, which is saying there is no difference. So decision is based on what happens when you compare the p-value with the alpha value. And two things can happen. P-value will be less than the alpha. If it is so, then the test is significant. You are rejecting the null. And of course, you accept the alternative. When the reverse is the case, if the p-value is greater than the alpha, then you fail to reject the null, which means it is not statistically significant. So, Eddie Diong, yes, ask your question. Eddie Diong.
Yes, sir. Thank you, sir. Please, I not get the explanation when you mentioned that the decision occurs when we compare p-value and the other value. I did not get the explanation, sir. Thank you, sir.
It is, what I'm saying is even here, that the decision as to whether you should reject the null hypothesis or you should accept the null hypothesis is arrived at when you compare two things, the p-value, when you compare the p-value and the alpha value. When the p-value is less than the alpha value, then it says you reject. You reject. When the reverse is the case, in other words, you reject the null. When the p-value is greater than alpha, it means you fail to reject the null hypothesis. Is that clear, Edidion?
Yes, sir. Yes, sir. It's clear, sir. Thank you, sir.
Good. So when you reject the null, that is when the test is statistically significant. When you fail to reject, that is when the test is not statistically significant. So those are the terminologies that you have to use, because the hypothesis you are testing is a statistical hypothesis. Remember, there are other ways, outside, but this is a hypothesis that is using data. That's why it's called statistical hypothesis. It's based on evidence, from data, not from any other, belief or whatever. So you should always emphasize statistical hypothesis, or statistical significant, or statistical or not statistical significant. So you need to use those terminologies quite appropriately. So everybody should get used to these steps. These are the main steps involved in hypothesis testing, starting with formulation, selection of level of significance, choosing appropriate statistical test, computing the test statistic, comparing, and then taking decision. Those are the steps. So that leads us to two errors that can arise. Remember, we have the null versus the alternative. So two errors are possible, because we might remember we can reject from this test, from our decision. We can reject the null. We may also fail to reject the null. So error occurs when we reject the null, when the hypothesis is true, then there is an error. So this error of rejecting the null when it is actually true is the one we call type 1 error. So type 1 error, if they ask you, is the probability of rejecting the null when it is actually true. Example, if you conclude after you have compare your p-value and your alpha, and you conclude that men speak faster than women, when they actually don't, then you have committed a type 1 error. So this type 1 error is what is called the level of significance, alpha. That probability of committing that type 1 error is what we call alpha. So don't forget. The other error, and that error is also called false positive. That is when you are claiming that the hypothesis is not correct, or when you reject that a correct hypothesis. So correct there is positive. Then rejecting it is the false that we are talking about. So when you type 1 error is also referred to as false positive, and is an error that, yes, it's an error that we usually don't want to commit. And that's why the chance is assumed to be very, very small. Yes, Eddie Dion, are you still raising up your hand?
Yes.
Great.
I'm confused about the type 1 error.
Okay.
Yes, it's not really clear.
Okay, let's go back to this hypothesis, the hypothesis that we stated here. This hypothesis, there is no difference in speech rate between male and female speakers, right? I want you to be responding to me.
Yes.
So this is a typical null hypothesis, saying there is no difference. Now, suppose we now conclude that there is a difference, when in actual there is no difference. That implies that we have rejected this hypothesis when in actual the hypothesis is true. So if we conclude that there is a difference when in actual fact there is no difference in this hypothesis, then we are saying that we have committed type 1 error. Is that okay?
Yes, yes, Prof. Yes, I get it now.
The type 1 error is the error of rejecting a correct null hypothesis. Rejecting null hypothesis when it is true. Is that clear? Edidion.
Yes, Prof.
So
it's
that
clear.
is, in fact, this table will show you the difference between type 1 and type 2 errors. So, but we will come to that. The type 2 error is called a false negative. And it is the error you commit when you fail to reject the null, when it's actually true. In other words, when it is true, and you reject it, that's type 1 error. When you fail to reject it, when the alternative is true, then that is type 2 error. So you should know the difference now. So example, if you fail to detect a real difference in speech rate between 2 dialects, then you have committed type 2 error. this is a situation where you have failed to dictate real difference in speech rate, between two dialects. So there are many reasons that could be responsible for that. Yes, Eddie Dion.
Okay. I want to talk about this type 2 error. Can we say that it is the error made when we
Your network is breaking.
the null
Your network
hypothesis?
maybe it's fairly bad. Go on.
Okay, I want to clarify if the type 2 error is the error we made when we accept the null hypothesis and the claim is false. If that is correct.
You are correct. Yes. Or repeat yourself so that.
Okay. I said the type 2 error. If the is the error made when we accept the null hypothesis and the claim of the null hypothesis is false, if that is correct. That's accepting null hypothesis when the claim is false.
Yeah, is it when the null is false?
Yes.
Okay. So maybe for clarity purpose, let's look at this table. Can you see this table?
Yes, Prof.
Good. So this is the reality. And the reality is that there is no effect. We can also say the reality is that there is no difference. Right? In that case, H naught is true. Is that okay?
Yes.
Now, another reality is there is effect or there is a difference, right? And what that means is that the alternative is true.
Yes.
Now let's look at the decisions.
I don't understand your ears.
Eddie Young.
Yes, Prof, I'm with you.
Good. I had the background.
Yeah, sorry, sir.
Okay. Do you understand? This is the reality, which is what is the actual. The actual is that there is no effect. Is that okay?
Yes, sir.
Is that okay? Okay. So there is no effect, which means in reality, H naught is true. Now, a type 1 error will occur when you reject that claim in the null hypothesis. When you reject the true hypothesis, this null that is true, when you reject it, then you have committed type 1 error.
Yes. Yeah.
Is that okay?
Yes.
Good. Now, when you take a decision and that decision is to accept it, you fail to reject H naught, which means you accept this H naught is true. That decision is correct, true or false?
Please,
That
come
is-
again.
Okay. You must understand, otherwise we won't move forward.
We are trying to comprehend, bro.
I know you struggle a bit. Let's focus first on this side. So maybe this table will help you. Now, we are considering two types of errors, and we have two hypotheses. Hypothesis, the null hypothesis, which is saying no effect, and this hypothesis is true. This is the alternative, which is saying effect exists or there is a difference. This is the alternative. Now let's start with this one. If our decision is reject H naught, when we reject H naught here, remember the reality is what? H naught is true.
Yes.
Remember the reality is that H naught is true. Now, because H naught is true, but we have our decision here is that we have rejected it. What have we committed? Type 1 error. That is, we are raising false alarm.
He's not listening to himself here.
We are raising false alarm. Now, if our decision is to reject it,
Yes.
what has happened when we say there is no effect? Sorry, we fail to reject it. This is where we reject it. Here we fail to reject it. Remember, the reality is that no effect, H naught is true, and we fail to reject it. What is our decision correct or not?
It's correct, sir.
It's correct. It's true. The null hypothesis is true, but we fail to reject it. Fail to reject for now. Just take it as we accept it. So it means we have accepted the correct hypothesis. Is that okay?
Yes. Okay, sir.
So there is no error here. There is no error in this place. There is no error, but we have error here because we rejected it when it is true.
Yeah.
We rejected the null when it is true.
Yeah. That's true. That's right.
Thank you, Prof. Thank you.
Now
Yes.
let's move to this side. Let's move to this side. This side is saying it is the alternative that is true. There is a difference. Look at our decision. We reject H naught. And you know, when we reject H naught, we are going to accept H1. Isn't it? Nobody is responding again.
It's true. It is, sir.
So this is correct. There is no error committed here. Now, if the reality is that H1 is true, and when we take our decision, we fail to reject H naught. Remember, when we fail to reject H naught, it means we are accepting H1. So if we accept H1, if we accept H1, in other words, the reality is that there is a difference. So fail to reject H naught means we accept H naught and we reject H1. That's why there is type 2 error here. Fail to reject H naught means we are accepting H naught and we are rejecting H1. But H1 is actually the truth. That's why there is a type 2 error. So type 2 error is the error of accepting the null hypothesis, accepting the null hypothesis when the alternative is true. Any other question? Deborah?
Yes, sir, please. I just wanted to ask if this class is being recorded, sir.
If this class is being recorded,
Yes, sir.
I want to think so. Let me check. Yes, it's being recorded. And your voice has been recorded. Your contributions also have been recorded. Deborah,
Okay, sir. Thank you very much. Thank you very much, sir.
I know you are struggling to. Yes. Is there any quick question before I leave this page? So it's always very important that you are able to distinguish between the two. We still have a long way to go. So therefore, we must understand p-values. And by definition, you remember, we always compare p-value with the alpha value. So p-value is a value that tells us, is a value that tells us the probability, the likelihood of observing our result if the null hypothesis were true. And whenever the p-value is very low, very small, any value that is, we consider any value below 0.05, which is our alpha value, to be very low. Any value below this is considered. And the implication is that the smaller this value, then the stronger the evidence we have against the alternative hypothesis. So you can see how they are connected. The higher this p-value, then this, no, the smaller, no, the weaker, so to say, is the evidence that we have against the null hypothesis. So they are like they are in the reverse order. The lower the p-value, the smaller the p-value, the stronger the evidence we have against the null. Again, the weaker the p-value, the smaller the p-value, the weaker the evidence we have against the null hypothesis. That's the interpretation of your p-value. So when the p-value is low, it implies strong evidence against null hypothesis. It's saying you have sufficient evidence, no, convincing evidence, perhaps, to reject the null hypothesis. And when your p-value is very high, then that evidence is not weighty enough, it's not strong enough for you to reject the null hypothesis. So we have example, if the p-value is 0.02, it's less than 0.05, so which means the evidence is strong against null hypothesis, so we can reject it. If p, for instance, is 0.02, that value is greater than 0.05, so it means the evidence is weak. So always remember, low p-value implies strong evidence against the null. High p-value implies weak evidence against the null. So, which means in this case, p equals to 0.20 is saying that that evidence is not strong enough for you to reject the null. So you fail to reject it. But most researchers commit a lot of blunders. They abuse this concept. Sometimes they interpret it as measure of strength of an effect. It does not measure any strength. So it's only helping you to say whether your hypothesis is statistically significant or not. Remember, statistical significance occurs when you reject your null hypothesis. So when you have strong evidence against the null hypothesis. Statistical not significant occurs when you fail to reject the null hypothesis. So these are the common significance levels in linguistics, and I mentioned that before. It could be 0.1, 0.01, 0.05, which is the most commonly used. So you can always condition your mind to use 0.5. This sometimes is used if you are doing exploratory studies. This is very strong. 1%, is usually in medical or very sensitive, very highly, if when you are dealing with situations that or studies that are related to human, to survival, and things like that. So choosing your alpha depends on the field of study and the consequences of errors that you want. And as I said, in medical research, they go as far as just taking 1%. And in linguistics, 0.05 is a good standard. Now, we are now going to going back to our data. We are almost through. So in this case, we will start with one sample test. So let's look at our data again. Our data, we have speakers, 10 speakers, we have gender, we have the speech rate. So we want to test hypothesis about a single group. So in our data, how many groups do we have? You will see that we have two groups. One group under gender is we have the female group, male group, and we also have the female group. The male group, female group. If we are testing hypothesis about only one group, this time, let's say male, or we are testing hypothesis about female only, then we will talk about a single group. So what is the research question that we have posed here? we have posed the question as to whether speakers from certain dialects speak faster than the national average of 1,500 words per minute. The data we have is actually looking at the word count. You know? So we are testing whether speakers from a certain dialect, Yoruba, Igbo, or Hausa, as the case may be, speak faster than national average of 150 words per minute. So we can now state our hypothesis. This is the starting point, formulation of the hypothesis, or hypothesis formulation. So H naught is that the mean speech rate is 150 words per minute. And you remember, H naught, we always say there is no difference between the mean speech rate and whatever value is here. But the alternative, we always say there is a difference. So, which means the mean speech rate is different from 150 words per minute. And then the second step is to choose our alpha. We have chosen that to be 0.05. Then we have to compute these statistics. Even if you don't memorize, you don't need to memorize. But if you do, that's good for you. The formula is what you see there. The mean, the X bar, is the mean from the sample that we have taken. So the mu there is the population mean, which is the value that we hypothesized here. And then that's what we call the population mean. So then the S is the standard deviation sample. The N here is the sample size. So we can now compute that. And then we take a decision. Before we come to this, let's try this in our R environment. So that data that we have, let's bring it here in the R environment. So in that, I'm creating a data frame using the data.frame function so that I can store the data. In that, we have speaker 1 to 10, gender, speech rate. So I can bring this data to the R environment. So speaker from 1 to 10, that's what this one is doing. Gender, I use this collector, to collect all the genders, male. So because they are text, they have to be in quote. Then this is male, male, this for the first 5 speakers, female for the next 5 speakers. And then the speech rate, these are the 10 measurements. Then we can save them in or store them as speech data. So this line 3 to line 7 will run together. And then we can now see what is stored in speech data so that we will know that is the data that we have in mind. So if I run this, you will see the data now here. So which means you have the RStudio has been able to store the data that you have here. I hope you will also be able to generate your own data and test, use the same code to run your test. So having stored the data appropriately, we want to conduct one sample test. And as I told you, for one sample test, we can only deal with one group at a time. So which means we are testing hypotheses only about a single group. Maybe it could be male group, could be female group. So I think we are starting with the female group. So we are looking at female speakers. And we want to test if the mean speech rate of the females is different from 155. That is what you have here, mean speech rate for the female. I'm using 155 here. We could also use 150, but let's just keep to what I have here. So we are testing whether the mean speech rate for females is different from 155. So the hypothesis will be stated as you see here, mean speech rate for female, we have to put that, is equals to 155 versus mean speech rate for female is not equals to 155. So that is the hypothesis being tested in that case. And then this command or this line will now, first of all, bring out the female speech rate from the data. The female speech rate, they are only here. So it will bring out the female speech rate from that data. And that's why this particular part is there. It's only going to look at the gender variable and select only those that are female. So if you run this now, you may even want to see the data. It has selected only the data for the female, 150, 152, 149, 151, 148. That's the female speech rate. And then we can now use the t.test function to be able to carry out the test. And then you run this. Your mu here is the value, is equated to whatever value you are hypothesizing. So that's 155. Then you run this. Then you get this result, and you now see one sample t-test. So it tells you that the data is female speech rate, and the value you see here is the value computed here. So this is t, after substituting these values there. So that gives you minus 0.0711. The degree of freedom is the number of females minus 1. So you have 5 minus 1. That is 4. The p-value, which I said we need to be able to compare, that we will now compare with our alpha value. Remember, the p-value Yes, I showed you here that you will now compare the p-value with the alpha value as we discussed here. So, and remember, this value, our alpha value is 0.05. And this value is so small, smaller than the alpha value. And you know what we said, whenever the p-value is smaller, then it means we have strong evidence against the null hypothesis, which means this, as I said earlier, the smaller the p-value, then the stronger the evidence we have against the null hypothesis. So which means we have very strong evidence to reject the null hypothesis. In this case, we have strong evidence to reject the null hypothesis. And good enough, R gives you the alternative hypothesis, which is true mean is not equals to 155. True mean is not equals to 155. And if you are to take a decision, because you have, based on this p-value, which is less than 0.05, you have strong evidence to reject the null hypothesis. Remember, the null hypothesis will then become the mean is equal to 155, when the alternative is saying the true mean is not equals to 155. But now the evidence is overwhelming. The evidence against the null hypothesis is overwhelming. So we reject the null hypothesis. And then we conclude that the true mean is not equals to 155. That is, the true mean speech rate for female is not equals to 155. So we have chosen 0.05 as our alpha level, but if you look at the complement of 0.05, that is 95%, and that represents the confidence level. So which means even with this decision, we have 95% kind of confidence. But that again leads to what we call the confidence interval, which gives you the range of possible values that the unknown mean, the unknown mean speech rate for female will lie. And that value is 148.0368 and 151.963. So in this case, you can see we say this is the 95% confidence level for the mean. Of course, your hypothesized value is not even in this. No, it's not even in this range. But your mean value is in this range. This is the mean of the 5 female speech rates that you have. And that value is here. Now, that is for female. We can also have the same thing for male. So we can run for male, the same process. So we only change here to male and then select only the male speech rates. So we can run this line. And if we want to see the male speech rates, these are the male speech rates. 155, 160, 162, 164, and so on. That's what we have here. 155, 160 for male. So up to 154. And then we can now carry on the test. So we run the test. So again, this is the T statistics, and this is the hypothesis, the alternative hypothesis. And you will see that in this case, the P value is 0.1347, which means this P value is greater than our 0.05. And that means we have weak evidence against the null hypothesis, which means we fail to reject the null hypothesis. And what is the null hypothesis? The true mean is equal to 155. The alternative is the one that is saying the true mean is not equal to 155. But the alternative is true mean is equal to 155. So we fail to reject that hypothesis. No, we fail to reject that hypothesis. So, which means we can conveniently conclude that the mean, yes, we can conveniently conclude that the true mean speech rate for male is equals to 155. Now, that's when we are testing one sample test. Before we go, just a few more minutes, we also talk about two sample tests. So in two sample tests, that's when we are comparing two independent groups. And in our data, we have two groups. We have the male and the female group. So we can compare the mean speech rate of male and the mean speech rate of female. So the mean speech rate for the two groups will now be compared here. And to do that, we say we are doing two, we are performing independent t-tests. So we can easily do that with our data. And then we use the t-test function, and then we specify the speech rate. The speech rate, I told you, is, in our case, our dependent variable. That's why it's on this side. And then gender is our independent variable. That's what, and this sign is tilde, which separates them. So dependent against the independent. And then the data is here. Then you always need to put that they are independent because we believe that the variables, the two groups are separate groups, you know. So, and that each group has equal variance. they have equal variances. So we can run this, and then we can print the result. And here now, we can interpret this is the T statistics. I hope, yeah, that's the T statistics. And then this is the degree of freedom, which is 5 plus 5 minus 2. 2 because we have two groups. That's why it is 8. And this is the p-value. And this p-value, because it's so small, then it means we have very strong evidence against the null hypothesis. And therefore, the alternative hypothesis is, which says the true difference in means between group female and group male is not equal to 0, which means there are, there is a difference between these two groups. And then you can see the mean for the group and the mean for female group and the mean for the male group, as earlier mentioned. So this is how we carry out a single t-test and a two independent t-test. I will encourage you to also take time to watch the video. So this is basically the summary of what we have learned today. Hypothesis testing, what is it? It allows researchers to make claims and validate the claim in linguistic data. Then your decision can be, is liable to error. You should know that. So you could commit type 1 error when you reject the correct hypothesis, and type 2 error when you accept a wrong hypothesis. The p-value is very important and is simply used to determine whether to reject the null or fail to reject the null. They don't measure the effect size. The one sample t-test was demonstrated, and a two sample t-test also was demonstrated in using linguistic data. Thank you very much. We've had about 5 minutes extra, but if there are questions, please let me know. Asaba, any question? Ganiyat, Eniola, Deborah, Edidion, Adedeji. Are there
No
questions?
questions for me, sir.
Everything is clear. Okay,
I'll go
Kasaba.
and watch it.
Eh?
I will rewatch and re-listen to the lecture, sir.
Okay, Deborah, thank you for promising to rewatch. Cassava, oh, you have disappeared. Is Cassava there? I can't hear you. Edidion, yes. Unmute and speak to your mic.
Okay, thank you very much, sir. Actually, I think I've understood everything that we've discussed today, and I'm very happy about that. Thank you very much.
So clap for yourself. Clap for yourself.
Okay, that's notwithstanding. There's this one I want to confirm this. We said that if a research is not statistically significant,
yes.
No,
I said that you could have have hypotheses that are not statistical.
Okay.
They are not based on data, as we have used data now. But statistical hypotheses, they are based on data, and the decisions, they follow the standard procedure that I highlighted.
Okay. Thank you very much, sir. It was wonderful today. Thank you.
Yeah, unlike the last time. Cassava, yes.
Yes, sir. I want to ask if this. Thank you very much, sir, for the class, sir. I want to ask if this procedure, if this t-test, we can use it for questionnaire.
Yes, now you can use it for questionnaire but you must have your research question. You can see the way I put my research question, and then how we now formulated the hypothesis from the research question. Of course, your data can now be collected using survey data or using experimental data, as the case may be. But you must know, if you are comparing groups, then you must know what you are measuring, which will be your dependent variable, and the groups, which will be your independent variable. So if you have only two groups, then you use t-test. If you have two or more groups, then you, of course, you use the ANOVA. We have not talked about that.
All right, sir. Thank you very much, sir.
Any other question, good or bad? So see you next week. Robert, I thought I thought you are trying to.
Yes, sir. Yes, sir. My prof, I wanted to say that we'll still go back to lecture because there are so many things we still need to wrap our head on. So we'll be able to relate later, sir. Thank you, sir.
I want to encourage you to be rugged in this computational linguistics. I mean, I know the challenge, but tough times don't last, but tough people, I've been told they last longer than the tough time. So thank you very much, and see you next week, hopefully. Bye.